Did that work? I think we're live. Oh, holy, we're live. Okay. Yeah, you can't have a part 13 without something going wrong. Okay, so it looks like we're live. We're going to go live on radio as well, so that there's a chance that someone actually sees us. Okay. So I need the URL for this video stream. Hopefully I can find that somehow. Not the stream URL, because that would be too easy. Get shareable link, that's what I want. Yeah. Oh, not like that. Nope. Nope, that's not. Okay. This is how people will find us. If you don't believe me, just watch. Okay, it says we're playing. Did that actually work though? I think I want that URL instead. Great, now we are publish Sunkworks part 13. Ride the Galactic Radio. Great. Now people can find us on the internet. I need to keep this tab open though, or else they will not be able to find us. And also there is the YouTube chat window. I think you can probably still find me this way. Hello, YouTube chat. Concurrent viewers. It says 0, but I think that we're watching now, so we should be seeing that number go up by 1 in a minute. Unless they can identify that it's me and discount that. How do I make sure that we don't get any audio crosstalk or performance crosstalk? Turn the stream rate way down to make sure we are at maximum bit rate. Okay. That looks good. Okay, so I said we're going to build some stuff. Here I have, sorry. Fiddly thing. I have to fiddle a thing real quick. Alright. Just have to be able to see myself or else I can't tell if it's working. And that 144p was a little bit too grainy. To be of any use. Okay. So, some real talk. I don't know if you know what this is, but I have to fill out one of these. And I'm so embarrassed. Alright. Now that that's over with, let's build some shit. We are going to work with ChatGPT today. I tried to do this the other day, and it did not work for me because I asked for too much all at once. So this is too much all at once. What we need to do is do one of these things. Well, first. Okay. Alright, so I'm going to try something else instead. We're going to start with the, actually there's a whole separate, we're going to start with the architecture decision records. That's what we want to do. We want to produce a good architecture decision record with ChatGPT. You are a skilled Ruby programmer and project manager. you know how to make mermaid diagrams and markdown documents. You can embed the diagrams in the documents. We are going to diagram a concept and then elaborate it into a series of instances of project. We need to produce an architecture record every time we make a meaningful decision about how the project should be made for any given instance, insofar as there may be variance between the instances of the project and the overall concept design. Okay, so what I'm trying to explain to ChatGPT here is that we are going to build a program, and we're not just going to build one program. We might build multiple programs over the course of the next few weeks. But each program is going to run a particular kind of way. It's either going to run and produce some content or product or output, or it is going to run and remain resident as a service so that when you reach out to it, it can serve your request. Those are the two main designs for a Ruby app that I would like for ChatGPT to document first. Okay, so the third design, I'll give you the peek into the future. Actually, the third design is the serverless, which is a hybrid of those two. So there is a code that runs when your request comes in, but it is not running or resident all the time when you are not requesting the service. So I'm going to keep that out of the discussion with ChatGPT until I'm sure that it can fully differentiate between those two types, serving and job. And then we're going to take our architecture decision records and elaborate them for the projects that we have. So I'll just tell you right now that we already have some Ruby projects, and some of them are not just Ruby. Some of them are also JavaScript. So there is a website. This website is implemented entirely in JavaScript where I track some things that I would like to do. Like, for example, I would like to move my blog to Bartholomew. That's one of the things on the list here. And it looks red and bad because there are a lot of things that I've thought I would do that I marked down on here and they haven't all gotten done. But some things have gotten done. You can see there are lots of things that have gotten done. And actually it keeps track of the percent up here. So there's a spec for this. And this is one of the apps. I would like to make serverless. So that's what where we're going. Bottom line is we're going to take apps that exist that are already hosted one way or another. So another app runs, it's called simplest commit B. Simplest commit B. Okay. And this runs more like a cron. It runs every 4 hours to check this web page to see if anything new has popped up or if anything new is finished. And it gives me points for either of those. I get a point on this graph. And any time that something is finished or something is newly committed to, they both go on this graph the same way. Okay. So that is a Ruby app, and it runs with a Heroku build pack for Ruby, I guess, or a Docker file. I think it can run either way. In this case, it's actually a hybrid because it runs on Deis workflow, so it can have a Docker file and a proc file both, which is really neat, but not the point of this whole discussion. So yeah, so back to ChatGPT, we're going to accept his recommendation on how to implement an architecture decision record, and we're just going to let him draft 2 architecture decision records for something that runs as a service or something that runs as a job. And the job we can further differentiate into jobs that run only once or jobs that run on a ongoing and recurring basis. Maybe that will be part of his decision record, or maybe we'll leave that part unspecified for now. But just to know, there are several of these apps. There's another one here called OB Mirror. OB Mirror. OB comes up with some interesting type ahead find. Let's see. Package OB Mirror. Takes you back to the Git repo. Yeah, so this is another simpler app that does not have the full implementation here from that. It only has a Docker file, it does not have a proc file, and it only has a web process, I guess. I'm not sure how this works exactly. I think actually what I think is this is the active branch right now, and it does use a proc file still. And we need to replace this at some point. Oops. Yeah, it's 4 years ago we built this. It's definitely dated. We need to modernize this and turn it into a job that runs on Kubernetes using Kubernetes job, I think. But we'll get into that as we get into further specifying the job. Just to note that we already have multiple kinds of jobs that run, and they're important. For this one, it's important that this graph gets updated, or eventually I will pay some money. This is how this works. It's bminder. So it has a business function, but it's not exactly useful. More like a Rube Goldberg. But the definition of a Rube Goldberg machine is it's a machine that does some work. So that's interesting, isn't it? Okay, so all right, so we've got a lot of these, and what I would really like in the end is a diagram that shows all of these, but we're going to get there one piece at a time with ChatGPT. So we'll have different decision records, and we'll definitely have at least one decision record for each of these that has different implementations. But why don't we just look at the list right now while we're still here. So on Heffy stage here, where I have my Heffy workflow instance deployed, let's see if we can log in. It looks like it's working. That's good. We have a blog, which is certainly serving. We have Deis workflow itself, which is probably not going to be on the list. We have a web process. I think this one is gosh, I don't know. It's a slug runner. Okay. I don't know. I don't even know what this is. Is this moonboo.space? No, it's not that. Is there an ingress? No. Moonboo space. Can we... I think I can do this without breaking the stream. I'm just going to connect to Tailscale real quick and curl this to see what kind of response we get. Oh, there's something here. Oh, this is... I know what this is. Hey! This is the wedding website. Okay? Something went wrong. That was the wrong password. Wait a minute. Nope, that wasn't it either. Nope, that wasn't it. You know what? This might not have a database behind it anymore. I think that's what's wrong with this. Alright, well, that's interesting. But it's from our wedding. Here, that's what this is. Yeah, March 19th. That's my anniversary. Welcome. Welcome to my home. Okay, let's get back to ChatGPT. That sounds great. Let's create 2 ADRs. One for a process that serves a website, and one for a process that runs in the structure of a job. The job may run on a great. So we're going to add a fourth application type now. We're going to add the cron requester that triggers a Kata job like this on a cron schedule in an efficient way. All right, let's add a fourth application type now. The HTTP serverless process could have a side effect. We could run some cron schedule job that simply calls an HTTP service and reports in exit status about the success or failure of the request. It does not need to know or care if the server process is serverless or not. It will behave the same, and we can measure the performance of the serverless process externally this way. It should output a JSON blob that tells the it should also use the exit status to signal failure of the job in case all right, so this looks like a really nice spec. Now we've got 4 ADRs. Yeah, okay, so I wanted to show you all of the pods, not just the one. So there's a lot of things running here on the Heavy Stage cluster. Let's see. Some of them are even in error. Let's see. So we mentioned that we have potentially error state that we need to monitor for, and I'll show you what that looks like right now. We've got two different ways that receive these error states. One is through what I'm going to call the stateful alerting, which is either surprise, actually Flux alerting is stateful, well, even though Flux itself is stateless. Flux alerting is stateful because it monitors states of Flux resources. So you can see here that the state transitioned to a failure state, context deadline exceeded, and then within a minute it came back to regular state. All right, and another instance of failure here. We see cube pod crash looping. Here's something went wrong on Wednesday a while ago. So this is the channel that you like to see relatively quiet, because if something is wrong, then it shows up here, and we actually see something is wrong here. So let's clear one of these alerts. We've got two alerts open. I see this pod is in failure state. We ran some builds manually. One of them failed. The rest of them really don't need to stay around either. So this is not an automated process. We ran those builds manually. And we'll see within a minute or so, one of these alerts goes away. All right, and the other thing that we see here is we tried to create a cluster that failed. And we can go back and make that cluster succeed now if we want. I'm pretty sure we will be able to do that. Let's see if we can do that. It's this cluster 03, which actually isn't defined there. It's in a different castle. We want to look at the, not the management cluster. I think we actually want to look at Howard Moon Boost Base clusters default cluster 03. Okay. Make sure we have the latest version. And I'll show you what's wrong here. We're trying to pass in these extra args, and we're just not able to use the extra args like that. Maybe we could use them like this, but I'm not sure that Syncer is the thing. I think it's actually the kubelet or the kube ADM kube API server that needs these. So we're just going to take them out because I think that it will work without that. And we'll have to find another way to log into that cluster, but that's okay. That's not a tricky challenge. And I'm going to take this part out because they're not relevant or correct anymore. And we're going to delete this cluster and try and create it again. Just make sure we get that commit synced into the cluster. All right, we see a cluster is created. We see some things are happening. I don't know if you can hear that. Probably even through my microphone you can. Okay, so this is the second type of alert. I'm calling this the stateless, spammy style of alert. We're going to get errors until everything is fine. And it's really okay. Here it says, actually it says CubePod not ready. Okay, so we resolved that alert. See, the stateful alerts take a little while to transition, even though so we see some different alerts here. We see Cube pod crashing. Okay, so this one. So these alerts have a fuzz factor built into them so that we can sort of avoid cube state metrics, so that we can avoid making too much noise. Basically, the stateful alerts are all built around only reporting really serious issues and not random noise. So, well, so it's still crash loop back off. So, unknown component default PSP. I don't know what that is. So I guess I'm just going to delete this cluster for now. We're going to try again with Cosmotron, because I think we'll have better luck than the vCluster provider. I'm not really sure, but I've been coached. Cluster 03. All right, so we want to make the errors go away, though. That's really what we're trying to do right now. And can reconcile that source one more time. And now it's gone. Okay. So we can put it back later if we want, but... All right, back to what I was trying to show you. I wanted to make sure you get to see all of the things that are running on the Heavy Workflow cluster, which are all of the things that we're going to diagram in the end. That is my goal, is to show the progression from simplest to most complex. And there's a whole spectrum of apps in here. So there's the commits to app itself, which has both a staging and an alpha deployment. The alpha, it's called alpha because it's in alpha. It's not production, but it is the production commits.to. Actually, you can see here, we've got our, we don't have an ingress for that. I don't know how it works. I guess the ingress is hosted somewhere else. Maybe on the management cluster. I think we're using traffic for this. Ingress route. Yes, we've got one called commits to. So in here, ingress route commits to serves up all these domains, and they all get pointed at one backend service. So this is an example of a thing that we're going to need an architecture decision record for, to say, how is this, you know, just to be aware that some apps do this. They don't just serve a single host, they serve a list of hosts. That list might need to come from a database at some point in the future. I'm not sure how we can handle that exactly gracefully, but at this point, it's not an issue. As long as all those names resolve to us, then we get to serve up a secure endpoint here, which you can see kb.commits.to is a secure endpoint, and we get our certificate generated on a regular basis. So it's automatically recycled as traffic does that. We don't have to have it ingress or cert manager at all. I think it's the same code on the back end. I don't know. All right, so that's one thing that we've got on here. Let's see, what else is there? There is simplest commit B itself that I mentioned, that does the polling, that puts the data point on the graph. There is all the things under the Deis namespace that are service deployment magic that we can document in an ADR as something that we'd like to move away from, because magic is bad. We should actually know what we're deploying. There is a deployment of a Ruby app here in the stats viewer That's default. Here we've got our several apps here. So this is a Ruby app that's not configured for everything. I'm not sure how you get into it, but this is it runs in production mode because otherwise we would see the big Ruby here. It's just a simple web page that runs Ruby. Again, something maybe we want to get away from doing if we are going to run a Ruby process in response to a request. Maybe we want to do that using Kata or something so that it's not always resident when we're not requesting. We don't want to see those pods taking up memory. Like, for example, oh, I can't do it here. Yeah, we need the metrics API for that. Just take my word for it that the Ruby... I know this is going to sound terrible. If you know me, I'm a Rubyist, and I'm not trying to diss Ruby, but just take my word for it that the Ruby apps take up a lot of memory, more than they need to on a continuous basis when they're not serving requests. None of them are actually performance critical, so if the request ever takes longer than a second or two, it's really not the end of the world. As long as we can show on a graph that the request was served successfully and it didn't error out, and that's what we can do with Kata and the HTTP add-on. I think we'll want to get Flagger involved as well. I think, and we'll have to figure out how to use a load tester so that Flagger. Well, maybe we do, maybe we don't. I don't know. Maybe that will just work itself out. I think that'll be a cool demo, though. Again, Kata scale to 0. We did a Kata demo at Prometheus Day. We never did scale to 0 demo, though. With anyway, so like I said, we have a blog. We have commits to a different website. So there's different websites on here. There's several instances of the blog. They don't need to be running. They don't actually need to be running Ruby at all. This is a Jekyll blog, so we could just spit out an HTML and run Nginx, which we can also do serverlessly with Kata. There's no reason that either one needs to be a resident process. We'll always have an Nginx process running to answer requests. It's going to forward that request to some process on the back end. Here we go. We've got resolved, so now our alert is resolved. That's great. It's not going to ping me for the rest of the night. Fingers crossed. Okay, so we can take a bulldog break. I'm going to take a little bulldog break here. We're not going to make Salisbury steak. I don't know if you could hear that. We are going to take a bulldog break. I'm going to go take a bulldog break, go pet the bulldog, make sure that she's happy, has everything that she needs. But you guys just enjoy the bulldog for now. I'm going to leave her here. I'll do full screen. How about that? That's much better. Okay, so I didn't say this very clearly before, but I'm going to say it now because I have to fill out this form. I am looking for work, so that is a work search activity. I'm looking for work. That's what I'm here to say. How did we get here? It's a long story. I'm not going to go into detail about it right now. If you know me personally and you want the story, I'll tell you the whole story, or as much as I can legally. But I'm going to take that bulldog break. Okay, I'm back. All right, I see. I still have no viewers. That's okay. I'm not gonna feel. I'm not gonna feel bad about it. But yeah. So to reiterate, for anyone who was barely paying attention before the break or who's just joining us, I am open to opportunities. And that's all I'm going to say about that right now. Unless you have further questions. Okay, so the reloader here is an artifact that we need because of the way that one of these apps is deployed. We had a list of ingresses here. Yeah, okay, so there's a docs website. There's another docs website that are actually functioning docs websites that are meant for people to consume. Even this one. Okay, so all of these clusters that I connect to here are available for developers to use. I'm not sure how much more there is to say about that, but it's been validated that this is not a really challenging. I mean, it is kind of challenging to set up as a user. This secret is copied from a guide, and this secret is not valid anymore. I could go in and update it, so you can just copy and paste. But the whole point of this guide is actually to enable you to not just copy and paste, but to have your own access to my working cluster that's here in my office. I've shared this with several people, and it's been effective for us to collaborate as a team. Middle effective, medium effective. We've had some success. We've definitely fleshed out issues in other docs. There are a lot of tools that you need to make this work, and depending on what kind of laptop you have, the experience differs. But we've been able to test it successfully, I think, on Windows, Mac, and Linux at this point. With different architectures. Everything works with different architectures. Of course, because why wouldn't it? Maybe that would be easier to read. Ah, great. Cool. Yeah. So the Deis components enable us to deploy an app. So almost all of these apps are deployed using Deis because it's just the easiest way for me. If you're really anyone else, I probably wouldn't tell you to run Deis or Heavy Workflow because it's not really actively maintained, and it's probably not safe for your business. There are businesses that run this. Sorry, I'm not going to tell you who they are, but and we don't have an adopters page, but it is productive and it's useful. I run it because I'm ostensibly supposed to maintain it. So if anyone is going to run it, then I should. And it is a challenge to keep it running on modern Kubernetes. If you have one and your Kubernetes is up to date, congratulations. I don't know what else to say. I'm still using Docker under Kubernetes. I'm not sure I can explain exactly how, but this, if we look at these with a wide view, we can see they're all running on one node. So that's a hint. that there is one Docker node on the network where the rest of the nodes, on the management cluster, you can see we have a bunch of nodes. Just a bunch of nodes. And here I'll show you those commands I was trying to run earlier. Hogs is an alias that sorts. So we can see actually Weave GitOps Enterprise MCCP cluster service is taking up the most RAM of everything. That's interesting. That is interesting. So this is just kubectl top pods, all namespaces. We can do the same with nodes, which we don't need to look at namespaces because there are only 3 nodes and they're not namespaced. We see there is a lot of memory, so it's really okay to take up a little bit of memory. But 7 gigs is kind of extravagant there. I wonder what that cluster service is doing. That really seems like an awful lot of memory. I wonder if we need that. And you can see there is a lot of stuff running on various clusters. Each vCluster is by and large in a namespace by itself. But this breaks down a little bit because the one named Howard Mumbu Space is actually a vCluster that also runs the cluster API and vCluster. So Howard Mumbu Space has additional vClusters inside of it. What? Yes, I know. It's amazing. How can you do that? Well, maybe we'll see in a future episode. But we see there's a lot of stuff running here on this cluster. And least of which is Kube API server. Here, let's see. I guess the vClusters run a vCluster pod. Look at all of our stateful set pods here. There we go. Let's look at that alias. Oops. So we're using a sort flag -k to grab the 4th field. So I'd like to do that here actually with an additional grep. I guess we can just do hogs and grep. I'm not sure if we can. Let's find out. Oops. We sure can. All right. These are all of our stateful sets. And we can see this is an API server that is taken up quite a bit. That's the one that runs all the vClusters. So that's not really a big surprise, I suppose. And our top level API server is running even more pods, and it is, this is Howard Mumbu 1774. Where is that one API server? 1825. So the top level one is running, and it's even more. And they're taking up quite a lot of CPU. It would be great if we could shut those off. But you see, the smaller it gets, the less that number is. And the Rails processes, well, they actually don't seem to be taking up that much. How much? This is actually a Node.js process. And that must be the one that's serving up all the requests. That's another vCluster. Alright, so we're going to cap the infomercial there today. I think that's a fairly decent episode 13. So tune in next time for more delicious news and more fun with ChatGPT. The example that I'd like to work through, stats tracker GH, I'd like to work through this one from end to end. This has the best build pipeline of all of the, and it's also it's got some crap gemmed in there that we need to take out because the WebAssembly stuff shouldn't be part of the Ruby demo unless we really want it. But so far, I think the Ruby stuff has legs and stands on its own, so I'd like to take the WebAssembly and spin it off into a separate bundle that has its own release and own version before we make this one too complicated. So we will have a separate, if you look at this right now, the way the release assets are, there is a WASM that's bundled as part of this and the source code for the Ruby app. There's no need for both to be here, so we will not do that anymore. We will take this and publish it as its own. And just for reference here, this is the lib stat module. Alright, this is just a module that does some statistic. It's not really important what it is. We're tracking the number of downloads on the Flux website or something. I forget what it is. We have to read a file in order to do it. That's what this says. And if we go up to the library itself, should be self-contained. It's just doing a count with a big selector, which we haven't even parameterized. It's just one job it has. That's it. Just find the number on the page and return it as a int64, since it's a very big number. So we're going to spin that out into a libstat and publish it as a Rust cargo, whatever, however you're supposed to do that if you're publishing something in the Rust ecosystem. I really have no idea. We may not even do it correctly, and we just need to be able to replicate this behavior here, where I will show you that the WebAssembly gets downloaded into the build. There's a build that does download the latest version of the WebAssembly. So if we look at develop, we're building Wabbit binary, and we're doing all sorts of stuff to produce a WebAssembly. And we do that only if we're building the base image. Otherwise, we're just restoring the result of that from our cache. So that happens somehow in here. Don't ask me how. And we're going to spin that out so that instead of fetching from the cache where we can keep that develop workflow. Well, that's the rub there, isn't it? I think that's the reason why this is built this way. But we don't want it to stay that way. We want to develop the WebAssembly separately from the Ruby app. Okay, so this is the publish workflow, which does publish build WASM. Okay, if you're building a base image, it publishes to a cache. We just want to fetch from the release. I think that's what we're doing in CI. Do we even use the WebAssembly in CI? I'm not sure. Ah, the execute. All right. So this is the cron job. Yeah, so we were talking earlier about how we would run something as a cron trigger. And this is the cron trigger that we were running. So this is probably the most elaborate cron trigger that we could design. And it might be worth an ADR at some point to explore why is this designed this way. But this is the one that runs the Kubernetes operators. So there's a foreman here, because if you're running a Kubernetes operator without foreman, what are you even doing? I'm sure. And we are downloading the latest stat.wasm. So we can do this from any repository. It doesn't have to be this repo. We know the latest tag because we have a job that fetches it. Where is that? Output. Steps.checkout.output. Here, checkout latest tag. Git describe tags. So we do only know the latest tag because, all right, so we're going to borrow some code from the Flux repo. This is interesting, actually. All right, so we were able to tell the latest version because it was our version, and we had a checkout of the repo. So we could look at the latest tag sorted by how tags are sorted. I'm not sure if that's the correct way to sort tags. Get rev list tags max count equals 1. I guess that is the latest tag by the strict definition of latest, but not by the semver. So we'll do better. We'll use the Flux code, which I will show you, that looks up the latest release from a repository using a GitHub token so that we don't get rate limited by the API. And that one is also definitely worth an ADR. Let's see. Here's update.yaml, which runs a script. Oh, this is not the one I want. I think I want action. So somewhere in here there's a bit of code that looks, yeah, this is it. Looks to see if we passed in a version. And if we passed in version, then we don't have to look for the latest. Or if we passed in latest, then explicitly we passed in latest, so we need to use our token, all right? And we have an input here, GitHub token. So you can override the token. You can pass in a token explicitly, or we're just going to use the ambient GitHub token, since we can assume that there is one, since this is a GitHub workflow. You can actually assume that. Whether it gives you any permissions or not is typically an issue, but in this case it's not, because we only need to read the releases API to find the latest release. And this may have the same problem for all we know, but Flux will not publish releases out of order, so it's not an issue here. I thought we would do better, but I guess that's the best we're going to do. All right, so anyway, we get the latest tag, set up Ruby, set up Kubernetes, and we run this make foreman. I'll show you what this make foreman does. Actually, I've already shown you what this does. At the Open Source Summit, I showed everyone exactly what this does. I built up to it with the lightning talk at CDCon. Exotic runtime targets. There we go. Does this get you to the YouTube? Oh man, how do you get to the YouTube from here? Come on. Oh, there it is. All right, and also the ContainerCon. Longer version. Yeah. Yeah, so I did show this running. Hope to gain all these things. Built some things based on Rust app here. Yeah, so I've explained some of the architecture for this repo already once, but the architecture is in flux as we... The architecture is changing as we speak. Okay, so no funny puns, no funny business. Alright, so if you want to know in detail about how this works or actually see it run, you can follow those links. I'm not going to run it here, but I am going to show you what that foreman job does. It runs the proc file, which defines several things, 1, 2, 3, 4 things, that all run concurrently in separate Ruby processes, and they're each reconcilers. So they're 4 Kubernetes operators. And the Kubernetes operators are defined in the CLI. Okay, so the CLI runs each operator. So we'll look at libcli to see how are these operators defined and where. But here are the basics here. Those are the places where the 3 main reconcilers and then the 4th one that comes along later. So at a high level, the project reconciler takes a reference to a YAML. I'm looking for the manifests. Deploy. Overlays. No. Bases. Tests. Okay. So we've got this one, and we've got this one. So each of these reconcilers runs in approximately the same way. We declare an operator on a class that implements a module that implements the operator class. So there are multiple implementations of operator, like we were talking about having multiple implementations before. And then there's a measure method that can get called independently. There's some interaction between project and leaf. The project resource gets reconciled first to create all of these leaf resources. The leaf resources are supposed to become ready. And then when they become ready, the leaf resources are all measured by this measure method at the same time. So it's called a health check here, but really what we need is for all of the leaves to become ready within a short time, so that when we want to display the data on a graph, which of course we want to capture data into a graph, that's what we're doing here, so we can show it off later. When we do that, the data points all sort of line up on their own. We don't have to do any manipulation to make sure that they are lined up. And we still do some manipulation to make them line up, but oh, I have to acknowledge that I'm not a robot in order to get to graph. That's very interesting. I assume that doesn't make it take any longer, but I'm sure it takes a little bit longer. So the first thing that happens is we're just going off to find all the leaves, and the leaves are repositories, which is a little bit different than Git repositories because these are package repositories. So one Git repository can publish multiple package repositories, as we've already seen we're doing in this case. Here we go. I want to log in with my, probably this account. Okay, cool. So we want to see the number of downloads. And this is run in that GitHub workflow that we were looking at back here. Execute every 2 minutes after every hour. So we should see, yeah, we see there's some gap between the downloads, but there's some smoothing that's done so we don't have to. Okay, so this is all real data, and it's been collected over the span of several months since OSS Summit. Minus gap. Sorry, it was down. I didn't have the alerting set up yet. But this shows us the number of downloads. Yeah, you can see the gap here if you're keen. Of each controller. And if we go to the Flux website, Flux CD, Flux 2, packages, go back up a level to source controller. Here we can see that number. This is the number 61841211778. So if we go back here, we should see that's pretty close to the latest number we got here. 61839799209. Yep. And we can shorten this if we want to see individual data points rather than so many here. So we see it collects data once an hour. Yep, and that's our latest data point. And this is what we want to get to, but a little bit more elegantly, I think, than what we've done in the stats tracker example. So this is live now, and it runs Make-Foreman, and Make-Foreman just runs the CLI with all of the, right, date and time foreman. So we can see that it runs, and it runs pretty quickly. It takes about 1.5 minutes, which, who's to say if that's a long time or a short time, because it has to spin up an entire Kubernetes cluster and set up Ruby, and some of this is able to be cached, so the setup Ruby only takes 6 seconds, and it's not downloading any new gems. It's already cached the gems, so that's great. Setup Kubernetes takes 45 seconds, which is almost half of the time, so I guess it's okay that our test takes about 30 seconds, because it would be a shame for it to take much less than that, given the spin-up time for Kubernetes is about 45 seconds. So this is not a great design, the way it runs. It probably could do without the Kubernetes operator if we needed it to be efficient. But all of that can go in the architecture decision records as we build our product, whatever it is. We're going to build something, though. That's for sure. But here, that's that measure process that I was saying. Once it successfully cleans up all of the resources after it's done. So this is you know, it's not short-circuiting anything. We could just cut and run because this is a kind cluster that's disposable, but this process is designed to be run as a job. So you would like it if you could have the Kubernetes cluster just ready to go. So you didn't have to provision it each time. That might be an enhancement that might make this whole thing run a lot faster. So before we reverse this whole decision, I don't want to lose track of the fact that we built a serverless operator here, but I would like for it to be a bit more efficient. And on that note, I guess we can end today. I think I've said everything that I need to say. Thanks for tuning in. It's been strange. I'll see you in the next episode. Peace.